Hello, everybody, and welcome to section 2.6, where we're going to be looking at limits at infinity and also asymptotes. So, limits at infinity, we're going way out here, and there is another name for this that you might have heard in your college algebra class or in your pre-calculus class. Depends where you took it. Limits at infinity are sometimes also called end behavior because as we're going out towards infinity, that's way, way out towards the ends of the graph. And so that's why this also gets that name of end behavior. It's what's going on with the function near the ends of infinity, ends of the graph. All right. So for our definitions here, we are going to be looking at limits as x approaches infinity. Okay, so if we have the limit as x approaches infinity of f of x equals L, this means that f of x gets close to L as x gets, usually in our limit definitions where it's x approaches c, we would say as x gets close to c. But remember here that things are a little bit different because infinity is not actually a number. So we can't approach infinity from both sides. Approaching infinity from the right and the left, that type of thing doesn't really work since infinity is not actually a number, and you especially can't approach infinity from above. So as we're getting close to L, as x gets sufficiently large, we just say sufficiently large. Okay, so the idea here is, yes, we would be working with very, very large numbers. So x getting close to infinity, x is just getting larger and larger and larger. And yes, there is a more precise definition for this, because you might be asking yourself, well, what is sufficient? Is a million sufficiently large? Is a billion sufficiently large? And that's going to depend. The more precise definitions for these, we won't really look at here in section 2.6. We don't talk about those precise definitions until we get to section 2.3. Remember, that's the one that we've skipped over, and we're going to cover that next time, actually, in the next section. So we don't really have more precise language at this point. Okay, so f of x gets close to some constant L as x gets sufficiently large. Now, for our next definition, we could approach negative infinity. So the limit as x approaches negative infinity of f of x equals L. That means about the same thing as above. F of x gets close to L as x gets sufficiently large, but in the negative direction. Okay, so very large negative numbers. Okay, so here we are looking at the function approaching a constant as x gets sufficiently large in either direction. So we might have something like this graphically. Okay, here's x. And as x gets sufficiently large, the function is going to approach a constant. So our function kind of flattens off and approaches some constant value. Okay, something like this is being approached. Okay, now that dashed line that I just drew in, that is something special. If we say that's the line y equals b, okay, equation of a horizontal line there, that line y equals b is called a horizontal asymptote. Okay, so y equals b is a horizontal asymptote of f of x if either the limit as x approaches infinity of f of x equals b. So that would be like this case that I've drawn here. As x is getting really, really large, it's flattening off to a y value of b. So it's approaching that horizontal line there. Or we could have that same thing happening in the negative direction, okay? Limit as x approaches negative infinity of f of x equals b. If either one of those are true, then b, y equals b, is a horizontal asymptote. All right, so remember that horizontal asymptotes, they can be approached from above like we've drawn here, or they could be approached from below like this. Okay, so that would be as x goes towards negative infinity, f of x is approaching b. All right. And a horizontal asymptote can actually be crossed over, unlike a vertical asymptote. So maybe our function in the middle does something like this. Yeah, it's a pretty good looking function there. All right. So yeah, this function has a horizontal asymptote of y equals b. And so that is also looking again at the idea of end behavior. As we get out towards the ends of this graph, the function is just tapering off to a constant value. Now in the next video, we'll look at how we're going to find these limits as x approaches positive and negative infinity.